Hi guys, I'm Thomas. I run a cybersecurity software business. My background is in pen testing and very much was on the sort of manual security testing up to about 2 years ago, where myself and a couple of my other co-founding team members decided that maybe there was a better way to try and look at pen testing and we quit our jobs, and then something really interesting happened, which was ChatGPT came out. And we sort of realised maybe there's an application for this. And all this time we saw loads and loads of conversations from loads and loads of different people, some of which were saying, this thing's going to take our job, it's going to completely put us out of business. Other people saying, this thing can't do what I can do, this thing isn't able to replace a person, and it's just a complete novelty thing. But then we started to see some of the more interesting conversations start to emerge with people talking about the idea that maybe using large language models isn't about replacing a person, it's about what we can do to actually augment what we're already doing and help to improve things. So I was really keen to just try and start a conversation about the kinds of ways that large language models can specifically be applied to application security, things that we might be already trying to do and failing to do that language models might be able to help with, and things that we simply didn't believe were possible before but might be able to do. And that's really what this whole talk's about. It's just a conversation to get your ideas too about ways that we might be able to get language models to help enable us to do a better job, really, at what we're trying to accomplish at the moment. So a quick show of hands in the room. Who of you uses AI in your day-to-day life? Anybody want to give an example? I will give you a random. Somebody give an example.
Summarizing information. Putting it into a data.
Cool. Who here is using AI to benefit a security function within the business? In what way? What's that? Cool. And has anybody managed to use AI to completely replace a human function in the business? No, so that's exactly the same response I get every single time. I think that it's fairly clear whenever I have these conversations with people that AI is not a replacement for a person, but it certainly is an opportunity for us to help a person, help prevent burnout, help prevent sort of exhaustion, and help deal with large volumes of data. So, to talk about how we might be able to use large language models to augment AppSec testing, I first want to talk about what I mean when I'm saying AppSec testing. I'll kind of break it down into 4 core things that go into a good AppSec program, or at least a traditional AppSec program. So the first thing is scoping, defining out what it is that you're supposed to be testing, and when you're supposed to be testing it. The second thing is reporting, communicating effectively your output. The third thing is automated scanning, picking up lots of the low-hanging fruit and doing things that are high volume. And then the fourth thing is manual testing. I'm going to touch, hopefully, on each of these a little bit through the talk. But to help me along with the talk, I had to, my brain works in a way where I need to visualize something in a real-life scenario. So I've kind of invented this company, Acme Limited. Hopefully you can sort of think along with me and imagine how this might work in a typical software development business. So Acme, they build a piece of HR software. They use large language models to help build it. Their primary goal is not to be a secure piece of software. That is something that they'd like to do, but their primary goal is to get new features and new functionality out there all the time. At the moment, they just get an annual pen test and they run a bit of DAST on the side of it. And it's working okay for them, but typically when they get pen tests done, it's still finding things. It's finding SQL injection, it's finding cross-site scripting. They've got no idea where these things come from, and they're just trying to battle them whenever they get that pen test report in. So let's look at what scoping today looks like for a company like Acme. So what would usually happen is somebody would come in They would sit down with their development team, they would try and understand what it is that needs to be tested, what the features of the application are, the functionality of the application is. They'd understand what the motivations behind that test is, and after maybe a half an hour conversation with 4 or 5 people, so that's like 2.5 hours worth of actual resource time, you come out with some sort of a summary that you're going to pass on to the tester. That's fine, but I really, really felt like this might be the first opportunity to start looking at ways to augment the AppSec process. So I started by looking at these things called guided workflows, and effectively what a guided workflow is you challenging the model to be able to present you with a series of questions, and these questions dynamically generate based on the answers that you give, that can then provide a summary in the format that you're looking for. And effectively, it's just question and answer. What this means is that rather than having to sit down for half an hour with 5 people in a team, you can just give them access to this model and they can have a conversation with the model. And what it spits out is a fairly high quality scope. And I thought that was brilliant, right? But the problem with that is the only person whose time that was saving in the whole process was my own. So to a customer, it wasn't actually that valuable. So then I started wondering, what if we didn't need to do this scoping conversation at all? And the way that we came about looking at removing the scoping was to say, where is all of this information already? You know, where can we go to be able to collect the information about what exists that needs testing, maybe what's been changed since the last pen test, and the information like that. And it's already existing inside businesses. It's inside high-level documentation. It's inside ticketing systems. It's already recorded, but the problem is usually it's recorded in 10,000 different Jira tickets, or it's recorded in 14 or 15 different pages of high-level documentation. It's the kind of stuff that a person doesn't have the capacity to trawl through to quickly generate a scope. But you can feed that information into a model. You can just provide it with all of that text, and it can trawl through. It's brilliant at trawling through loads and loads and loads of this information to be able to extract the key bits of value and present them back. So that was the first toe dipped into the water of using large language models, and I definitely think there's real opportunity there to be able to expedite the scoping process, so much so that you don't necessarily have to worry about doing these scopes once a year and relying on trying to update them or trying to redo them each and every time. What you can actually do is a cool thing where you actually keep the scope updated throughout the year. Every single time somebody makes a development change, you feed that in as further context to the model. It quickly, rapidly updates the scope so that whenever you want to kick that test off, that scope is always an up-to-date summary of exactly what there is and exactly how it might need to be tested. The second thing that I looked at was automated scanning. Now, automated scanning is really, really interesting because it's such a broad category. You've got SAS, you've got DAS, you've got RAS, you've got IaaS, you've got all sorts of different ways of going about to identify certain vulnerabilities. The problem is that it's only reliable at being able to identify about 80% of vulnerabilities at the moment. It depends on the vulnerability, right? It's brilliant at finding HTTP headers. It's awful at finding business logic flaws, for example. So I started to wonder whether or not I could go down the road of using AI to find the vulnerabilities that it wasn't very good at, and very, very quickly realized that actually loads and loads of other people are working on that problem, and hopefully they will be able to solve that problem. But in the absence of being able to do that myself, where could I use models to be able to help make the most of at least the information that these automated tools are able to produce? And there were really 2 areas that it seemed to make sense to be able to use the models. The first one was in being able to stitch together findings from multiple different sources to get a greater level of confidence. So if your SAS tool is telling you something and your DAS tool is telling you the same thing, then models are really, really good at being able to interpret and identify that in fact that scan finding from those 2 different scanners is actually the same finding. What that means is that while SAS is wrong say, the exact statistic is wrong something like 33% of the time, and that is wrong something like 15% of the time. If your model is able to determine that that SAS finding is the same finding that is that DAS finding, then actually that false positive rate goes down to something like 2%, which is an incredibly valuable way of being able to mitigate some of the challenges that you have around feeding your development team, your engineering team, with lots of results that they then read and realise aren't actually accurate, aren't actually that valuable. The second thing is in attack path mapping. So attack path mapping, for those of you who aren't familiar with it, is about describing the ways that you can chain multiple different vulnerabilities together in order to describe what an attacker might actually do. So attack path mapping is a good way of how you can understand that a lower risk vulnerability might actually be the primary vulnerability to focus on, because it's the thing that enables a load of other vulnerabilities to be exploited and to be abused. Attack path mapping on a small scale is really straightforward. If you've got 10 vulnerabilities within a report, you can start to imagine as a consultant, you can start to explain how those things can be tied together. But for a lot of organisations where there's 10,000 different vulnerabilities open at the same time, trying to understand how to connect all of those together and trying to draw all of that out is an incredibly challenging process. But these are the kinds of things where you can feed that in as context for a model, and you can ask it to explain to you how these things might connect in together. It's very good and very effective at being able to change the vulnerabilities that automated scanners have been able to find. So the next thing is manual testing, right? Manual testing is useful because humans can add value to testing in very specific ways, right? They are very capable of finding those business logic flaws, those complex identity and access control issues. But in order for them to do that, they have to turn over every single stone inside an application because they don't know where they should be looking. They don't know exactly what they should be looking for. And you end up with this situation where humans end up duplicating a lot of the same tests that automated tools are duplicating. And there's loads and loads of time that gets lost there. So, one of the things that I started looking at was ways that we might be able to actually use data from, again, ticketing systems and data from automated scanners to feed into a model and to start refining down that scope of what a person actually needs to look at, to say, you don't need to look at every single part of this system every single time for all of these vulnerabilities. All you actually need to do is look for the vulnerabilities you know that the automation isn't able to find, and in the places within the application that somebody's been working on and been developing on since that last pen test. And I'll come on to in a minute, there's some really cool tools that you can actually do to do this inside the SDLC, meaning that you can introduce these gates into the development process so that before you're going to deploy a piece of code to production, you can actually pick up on whether that piece of code can be tested automatically or needs to be tested manually for certain vulnerabilities. And the final area that I started looking at was reporting. So I don't want to teach anybody to suck eggs in terms of what we do with reporting at the moment. I don't really need to talk, I think, about how you can use a language model in order to facilitate your reporting. I'm sure anybody who's used ChatGPT can imagine where it has its value there. But what I did do was realise that it's useful to start defining some rules for where you should and where you shouldn't be using models, or how you should and shouldn't be using models in order to facilitate these landscapes. So these rules are some of the things that I find within our business as ways to try and optimise how we use models, right? LLMs are brilliant at writing generic descriptions and boilerplate text. They're really good at defining existing write-up, right? So you write something and you feel like actually it's the information's there, they could do with a bit of a better structure. They're really good at that. And they're also really good at customizing recommendations. Those are security testers. We're not developers, right? We don't necessarily communicate development languages. We don't necessarily know how to write the code that fixes the thing that we're able to build. But a model is a really useful way of being able to make much more bespoke recommendations Not necessarily always right, not necessarily infallible, but often able to communicate a lot better than a pen tester can how to go about fixing things. And I think that's only going to become more and more relevant as things like Copilot become much better at writing a lot of these pieces of code. There are also some demos, right? So sending a bunch of data to a third-party API like ChatGPT is obviously a risk that needs to be considered. It's not necessarily something that everybody does consider, but sending customer vulnerabilities to third parties is generally considered to be a no-no. Relying on the output of LLMs to be accurate. So one of the reasons why I don't think that an LLM is going to replace a person anytime particularly soon is why everybody hears about hallucinations, right? These things do intend things, these things do make statements that are so convincing in what they say, but so fundamentally inaccurate, that what you need to do if you're going to be able to use these things is you need to be confident in what the right answer is. You just don't necessarily have the time or the best words to be able to say it. If you can do that, then you can use the models. If you can't do that, it's probably better to get the foundations under your belt before you start using the model to facilitate it. And then the third thing is, don't waste your time trying to bypass the guardrails. I've burned many hours trying to find ways to be able to trick models, but for those of you who aren't familiar, guardrails are effectively the mechanism by which things like ChatGPT will refuse to write malware for you, will refuse to write payloads for you to be able to exploit various different vulnerabilities. And you can sometimes find ways, you can tell it that you're an old lady who's desperately needing it to be able to save her son from some wolf or something like that. Lots of people come up with all sorts of different ways to try and coerce the model into doing this. But honestly, you burn way more time by doing that than you would just by writing these things manually. So at a certain point, accept the limitations of these tools and go back to the old ways. So obviously, there are some things that I would definitely recommend in terms of resources to be able to facilitate if you are interested in helping augment your program. The first one is Claude. I mentioned ChatGPT loads. ChatGPT is obviously the really famous thing that everybody uses. But I've experimented with loads and loads of different models over the last couple of years, and Claude outperforms pretty much everything that I've seen in its ability to work. It's more technology focused, its ability to work with code, its ability to understand developers, and it's definitely where I'd be going instead of GPT if I was looking for a sort of foundational model to work from. The second thing is Hugging Face. So, for those of you not familiar, Hugging Face has loads and loads of both open source models and resources to teach you if you would like to build your own model. It's a really powerful place to go to if you're starting out and learning about developing these sorts of LLMs. But Ollama is a way to be able to cheat your way around to that way. If you want an offline model, you want a way to be able to host it. It's effectively Docker for offline models. So you no longer have to send vulnerabilities to a third party like Anthropic or like OpenAI. You can actually host a lot of this stuff on your own machine with very limited configuration in order to be able to do that. BirdGPT I've got on there just as an example of how other people are already implementing this kind of technology into the tools that a lot of us already use in application security testing. And I definitely recommend checking out what else is out there, because these things are going to continue to be introduced into the tool sets that we're already using. I think the early adopters of that are going to be the people who find that they're performing better in the long run. And then the final thing is red flag. This is what I mentioned earlier. So red flag is a tool that has been written to sit in front of a release cadence and make sure that certain pieces of development are not going out into production until they've been tested. It says this is a high-risk change that needs to be manually tested for these kinds of vulnerabilities. It's a really cool technology that was developed and released open source to be able to do that. I definitely recommend checking it out. And then finally, I wanted to just give a little strengths and weaknesses analysis of models. So these are some of the key areas that I've considered so far, but again, really interested in hearing some of your particular opinions on this. So, models are very clearly good at automating repetitive tasks, right? They're really, really good at processing large volumes of data and helping remove some of that burden from people so that testers can focus on what testers want to do, testing. They are less good at being accurate, right? They hallucinate. They're also less good around privacy concerns and lots of risks associated with sending the data off to third parties, as I've already sort of touched on. And they're not very good at explaining their reasoning behind things. So often they can sound very, very confident, but you've got absolutely no idea how they actually ended up saying the thing that they were saying, which makes it very, very difficult, unless you deeply understand what the correct answer is, to know whether or not what they're saying is the truth. Their opportunities, mass adoption by tooling, as I've already said. So as people start to adopt this stuff more, I can only foresee that the maturity of the capabilities is going to accelerate. People are going to come up with new ways to solve some of these problems. And RAG and semantic searching are two perfect examples of this, right? So people complained about hallucinations and people complained about the lack of rationalization behind the decisions that these models were making. But with retrieval augmented generation, you're able to give a model real-time access to much more up-to-date data that it can actually reference and use to be able to massively reduce the number of hallucinations and to be able to say, I got this data from this place and I've made this decision because of this thing, which only a few years ago we couldn't do with a model, and is now a really, really powerful tool. Another opportunity is SLMs and distilled models. So we all talk about large language models, and they're brilliant, right? But large language models take massive amounts of resource and compute power. SLMs are small language models. They're effectively the kinds of things that you're seeing operating on your phone now, entirely offline. They're very, very simple. They're built for a very refined purpose. But they're a great way to be able to avoid some of the limitations and some of the challenges that we're seeing when you're trying to run a 70 billion parameter model, for example. Some of the threats to talk about, and I've left this till the end because that's my security brain doing what security people do and talking about the bad things. It's a relatively unknown attack surface, right? So what I'm talking about here is that we actually don't know all of the vulnerabilities that models might be exposed to. We hear about things like parameter leakage or prompt injection, and people are talking about the kinds of ways that these models might actually be exploited. But it's still a relatively unknown quantity at the moment. And that's definitely something that is concerning, but hopefully also quite exciting for a lot of people who are interested in finding out how we might go about exploiting and then ideally how we might go about securing these models in the future. The next thing is regulatory and contractual restrictions, right? So this is, there is regulation coming in, there's already been some regulation coming in to be able to limit the way that we're using these models. So if you're going to go away and try and automate your AppSec program, just be cognizant of the fact that you might not actually be committed to train it on some of the data that you might like to train it on, or be prepared that if you are restricted in the way that you're going to use that, you're not using it for life-critical systems, for example, or be aware if you are doing that somebody might come along in the future and tell you that that's no longer allowed. And then finally, hype-driven decisions. So this is going back to what I said right at the very beginning. So I really do believe that there are applications for models inside the AppSec program. I think I've given a few examples of areas where I can definitely see this being used to augment the program in the future. But I also think a lot of people are really, really excited still about using these models for the wrong things, about replacing people with them, about just adopting them in places that they don't need to be, right? I don't think that we need to use a model to find seek injection vulnerabilities, but seeking map has been able to do that for decades. And so I think that trying to keep focus on those areas where we are struggling already inside security is a really, really important thing to be able to mitigate the risk of us just using models in places that actually models underperform compared to traditional methods. And that's my sort of general SWOT analysis of models, and that's kind of the talk. Interested to hear from you guys if you've got anything opinions or anything like that.
How advanced as algorithms towards AI because they look at it. This is great. You're going to save time, you're going to save money, this is wonderful, but we have to establish that control using anything to do.
Yeah, and it's tough to try to convince people to do something if they've got a big phone against it. What I'd say is that I've tried to look at ways of using models to do, or using AI to do things that we are currently failing to do entirely, which is a much easier decision. You know, I hear people say all the time, yeah, but what if it makes a mistake? If it makes a mistake 5% of the time, 10% of the time, 90% of the time, but it gets it right 10% of the time, that doesn't remove nothing, then already it's a no-brainer why you be able to try and do it. I think the other thing as well is it's important to be prepared with the defensibility around things like not sending the data to third parties, around understanding what the strengths and weaknesses are, so you're just sort of play the safe around and say, actually, no, this is, you know, I've got a reason why I'm doing this, I've considered the risk, I've considered the rewards, and at the end of the day, if they're going to say no to that, then you go and find somebody else who says yes.
There is a situation where the solution is you just don't go to the next round, you don't score 10 and so keep in mind that there are thousands of things you need to do every year. So that makes it because they have to know all of the information. There are a lot of meetings. You have to know a lot of format. And
I'm a big fan of forgiveness rather than permission. A lot of situations, I think there's a lot of that ability. As long as you do consider the risk and you do communicate in a way that's not necessarily breaking the rules, but proving that a system works and then introducing it to people as even if it's going to be either I'm an advocate for rather than necessarily going and saying I want to do this big research. If you download OLAP or you download small 7 billion parameter models you can run on the local machine, you find a decent prompt that shows that it's able to do something like that trading exercise. And then you go to somebody and say, look, if it's able to do this thing, I've got other people to keep into to use it. Hopefully it's a much easier conversation to go to somebody and say, I think you need to spend X amount of resources and say, here's the model. You won't probably be able to use that along 7 billion parameters actively if you like, but the environment will certainly be able to demonstrate the value in a way that makes it much harder for people to argue against the position focus on AI.
So I guess you mentioned that processing a lot of today is a strength of LLMs. So I guess if you're going to try and process an extremely large amount of unstructured data to do some processing on that, and if you were not into visiting the context window size, I know that's something we discussed slightly earlier, but I'm curious whether that's a limitation or is that sort of a non-resident limitation? And I guess in addition to that, when you have this large amount of unstructured data, would you suggest like sort of chunking or how would you do that?
Yeah, so I mean, you can do it both ways. Our limitation, it can be a specific model limitation, but it is interesting to see a lot of research going on at the moment about the models work in very similar ways to research methods. And it works in similar ways to the way that we do, where we get loads and loads of data, and it's once we have the first bit of data we gave it, the last bit of data we gave it, kind of forgets the last data we give it in the middle. So yeah, it is something to be aware of and to be focusing on. Yeah, I usually suggest trying to things like finding something very similar. Like if you go past 10,000 tickets, for example, I wouldn't recommend trying to pass them all inside the same thread. Probably build a small context around what you're doing and then maybe pass 100 tickets. And ask it to make a decision on the back of that and then to generate the next context you feed the next help feed duration of over 500,000 people go. It's definitely implementation and that in our memory is it's a fascinating thing.
Just sort of context level, you discussed how sort of calculate SLM sort of is because obviously the set itself is like a lot of I said it.
Yeah, so one of the things that we're trying to do at the moment is train models to be able to make a decision about whether or not a specific change is being used by a developer as a vulnerability that needs to be tested manually or automatically or doesn't need to be tested or approved. So it's quick testing on the website, for example. And those kind of seem okay for the moment. I think the amount of installation still needs to go into that process. We get there, and not there yet. I'm not paying around that too much in that respect, but I'm really keen to building certain pipelines and effectively big on so hopefully we can get to a point where it's useful. I think there are a few applications for it. It's not
any more questions? If not, let's give Thomas a round of applause.